Welcome all to the next section of physics class. So now we are going to learn in detail about the chapter 8, that is current electricity. So we all are having different equipments in our home and also devices which we are using, which works under the electricity, or sometimes we will be calling it as electricity, sometimes we will call it as current, electric power. So these three things we have said: current, electricity and electric power. As a scientific view, this is a generally we are saying these words, but as a scientifically we can check it in detail about it, whether these three words are having the same meaning or the different ones. So now we will get into the next chapter, that is current electricity. What do you mean by current electricity? Current and electricity, right? Like that we will think. The current electricity mainly depends upon the charge. Okay. So first of all, we will learn about what do you mean by charge. Charge is a fundamental property of a body. So there are basically two types of charges are there: positive charge and negative charge. So we are aware about positive and negative charges. What is the SI unit of charge? That is Coulomb. So Coulomb is the SI unit of charge, and now you can see that how we are trying to represent it. That is called as one law is there. It is said as condensation of charge. That means all the charges exist in this universe, or any charge of any body we can write as a integral multiple of the smallest amount of charge. That is called as what? Q is the term we use to represent the charge. That is Q is equal to NE. Based upon whether it is a positive or negative, we can say it as generally we can say it as plus or minus NE. So this is what the representation of the charge. So now we have learned that what are the types of charges, positive and negative charges, and what is the unit of charge, Coulomb, and also how we can express it, how we can express the charge of a body as generally, that is plus or minus NE, and N is the number of charge, or which charge we are trying to represent, or number of electrons. This charge is basically we will say it as number of electrons based upon that, and also the E means the charge of the electron. What is the charge of the electron? 1.6 into 10 to the power minus 19 Coulomb. So here we know that there is a charge, and also when we are dealing with this charge, the energy or how a body get electrified based upon the electron flow. That means if a body is having more number of electrons, we say it as they are negatively charged, and if they are having less number of electrons, we say it as positively charged. This is how they are getting the positive and also the negative charges. So that's why we are trying to represent the value for or the condensation of charge. We can write as Q is equal to plus or minus NE, and N is the number of electrons and E is the charge of electron. That is, charge of the electron is 1.6 into 10 to the power minus 19 Coulomb. So now let's see, based upon this, what do you mean by charge we have learned. Next, when it comes to the current, how it is related. So what do you mean by current? When this charge itself we are considering with the time, that means rate of flow. I is the letter we use to denote the current, that is I is equal to charge upon time. That is the rate of flow of charge. When we are trying to consider the flow of the charge with the time, then that is called as what? Current. So that is, here we are considering what is the SI unit of it. That is, SI unit is what? Ampere. Based upon this equation, we can define what do you mean by 1 ampere. That is, equation for current is I is equal to Q upon T. I am just writing the units of these quantities. That is, 1 ampere is equal to what is the unit of charge? That is 1 Coulomb upon the SI unit of time, that is 1 second. That means when 1 Coulomb of charge flows in 1 second, we call it as that is 1 ampere current. If 1 Coulomb of charge flows in 1 second, then we can call it as 1 ampere of current flows through it. And here when we are considering the condensation, that is equation for the charge, that is Q is equal to plus or minus NE, again we can rewrite this equation, that is I is equal to NE upon T. So this is also another equation for the, and also there is a based upon the charge, that is I is equal to Q upon T. So this is what the main topic related to the current. Now we are going into detail about the current. What will be the direction of the current? See here, when we are connecting a battery, okay, that is a source. When we are connecting a battery to any external resistor is there, okay, any object we are connecting to a battery. So here we can see that the current always flows from positive to negative, okay, positive to negative, and also we can say that the current flow or the direction of the current will be opposite to the direction of the flow of electrons. Direction of current is opposite to direction of flow of electrons. And also here we are representing the direction, but normally in order to represent as a whole current, we don't need any direction. So that's why it is considered as current is a scalar quantity, okay. But when we are considering the direction of the current, we can see it as the direction of the current is opposite to the direction of the electrons. So normally we can say that when a battery is connected to an externally any device or any resistance, we can say that the current will be flowing from positive terminal to the negative terminal, and the electrons will be flowing from negative to positive.